In the 1920s, astronomers plotted the colour or temperature of stars against their luminosity in what is known as an HR diagram. Our Sun has a solar luminosity of 1 and a temperature of 6,000 degrees Kelvin. Stars cooler than the Sun are dimmer, while hotter stars are brighter. These are referred to as main sequence stars. But standing out from this logical order were some dim but hot stars. They can only be dim because they are small. In these so-called white dwarfs, normal fusion has ceased. Also puzzling are bright red stars. How could this be? If they are bright, they must have a large surface area to give off that much light, so they have to be big. But big stars should be blue, not red. So these red giants can't have the normal hydrogen fusion reaction either. We begin to solve these puzzles by plotting the stars of several different clusters. Clusters are born in nebulae. They are giant gas clouds of hydrogen and dust and are only just beginning to form stars. If we plot these stars on an HR diagram, we see that they are relatively cool. Only some of the stars have begun their fusion reactions. The gas in a nebula continues to collect and form stars to become an open cluster. We know that open clusters are relatively young because there are still hydrogen clouds between the stars. All of the stars in this cluster are on the main sequence. A globular cluster is old. There is no hydrogen between the stars. We see no blue or white stars, but there are red and yellow stars, as well as red giants and white dwarfs. This suggests that the blue and white stars have used up their fuel and disappeared long ago.